Hello and welcome back to another video. And as you can see, my background is different, and that is because I'm not in my home. I'm in my hostel room in my college. Yes, I've finally come to college, and it's tomorrow is about to be my 2 months over there. So well, now let's get to the question. So I'm gonna prove that n choose k is divisible by n if k is a natural number between 1 and n minus 1, or basically k is not equal to 0 or n, and n is an odd prime number, or basically n is a prime number not equal to 2. So let's get right ahead. Okay, so here is the question, and now this is more of a coding notation where the remainder of n choose k with respect to n is equal to 0, and as you can see over here that k is not equal to 0 or k is not equal to n, and k is a natural number, and well, k is also less than n, so basically k is a natural number within 1 and n minus 1, right? Okay, so, and we have n is prime. So, and this thing basically means that n choose k divided by n is equal to lambda for some lambda which is a natural number, right? So now, or if you take this on that side, we have n choose k is equal to n times lambda. Now let's expand n choose k, and as we know, n choose k is an integer, which, and n choose k can be written as n factorial divided by k factorial n minus k factorial, and that is an integer. Now we have n is prime. So let's take n outside, although that if taking n outside is not specific to n being prime or not, it's just a common factorial property. Divided by k factorial n minus k factorial, and now k is not equal to 0 or n, so let's just ignore those cases. Now now we can see that, and now for the time being, let's also ignore the cases where k is 1 or n minus 1. We will add those cases later, but let's not look at them right now. Alright, so basically this is what we have. We have this expression n choose k is equal to some mu, where mu is an integer and k is not equal to 0, 1, n minus 1 and n. Similarly, n minus k is not equal to 0, 1, n minus 1 and n. And because of this, we can see that k factorial is not equal to 1 and n minus k factorial is not equal to 1. And by the properties of factorial for natural numbers, where as 1 is the lowest possible value of factorial of a natural number can have, we have k factorial is a natural number greater than 1 and n minus k factorial is a natural number greater than 1. So now let's come back to this expression, and now we can see that k factorial cannot divide n. Why? Well, why am I saying that? Because if k factorial divides n, well, then that would be that we have a natural number which is greater than 1 which divides n, which is actually a prime number, and that would contradict the fact that n is a prime number. And now let's see what happens if we do n minus k. Well, n minus k, similarly for n minus k factorial, well, n minus k factorial cannot divide n. So, and now as this is an integer, we have n minus 1 factorial divides k factorial into n minus k factorial is actually some integer lambda k, where lambda k belongs to z, and this lambda's value depends on k. That's why I put this subscript. So now, well, we have n choose k is equal to lambda k into n, right? And that is, and if we divide it over here, we have n choose k by n is equal to lambda n. And now, well, I have told you about k factorial being greater than 1, but for a prime number is divisible by only two numbers, 1 and the number itself. And now what if, well, we have k factorial is not equal to 1, but what if k factorial is equal to the number itself? That would mean that k factorial does divide n. And now we can see that k factorial goes 1 into 2 into till n. And so it is a composite number, except if k is equal to 2, then k factorial is a prime number. So let me just look at that special case where k is equal to 2. So we have nC2, which is n into n minus 1 divided by 2. Well, so basically nC2 divided by n is n minus 1 divided by 2. So for this to be an integer, we need n to be of the form 2k plus 1 or 2k minus 1, and k is a natural number, right? And so basically we need n to be odd for nC2 to be divisible by n, right? And so basically we have nC2 is divisible, or nC2 divided by n is equal to lambda 2, that is an integer if n is odd. So basically this nCk is divisible by k for all k is not equal to 0 or k not equal to n, and n is an odd prime. So basically n is a prime number except 2. So n cannot be equal to 2, and there you go, and that's where we have it. So I hope you enjoyed this video, and if you did, like this video, comment on this video, and share it with your friends who you think might enjoy this kind of content. And for more such mathy content, please subscribe to my channel and spread the word.